Hi, happy people. This video is for the second lesson in pre-calculus. It's the composition of functions. So last time we learned how to put a number in a function, then we put an expression in a function. Today we're going to put a function in a function. Now remember, you can pause the video at any time if you want to write down anything that is on any of these slides. So a composition of a function, like I said, is putting a function within a function. So here we have g of f of x. This is how I'm going to usually show it. I like this form because it's just like any way you've seen a function before, is putting what we're going to plug in the parentheses. But another way you might see it is this g with a circle of f. So this means the same thing, g of f of x. That means we're putting the f function into g. So when it's listed this way, whatever is listed second is what we're putting in. For these functions, the domain of the function that we get out, so our domain of h, is going to be whatever the domains of the other two functions are going to be. So really all we have to worry about for domain, remember domain is the number we plug in, is are we dividing by 0? If you're dividing by 0, then there's going to be a number that is not part of your domain. All right, so here's what we're going to do to evaluate a composition. We're going to have, you're going to get a list of functions. I believe your homework assignment has 4 functions on it. And then you're going to be given either we're going to plug a number in to a function and then another function, or we're going to just plug a function into a function. So we're going to start with plugging in a number. So in this case, we're going to plug in 3 into the f function and then into the g function. So you're going to work your way from the inside out. We're going to start with the function inside the parentheses. We're going to simplify that. After we simplify that, we're going to plug what we get back into the outside, and that will be our answer. So we're going to do that example right there. So if we have f of x equals 2x minus 7, g of x equals x squared, and we want to find g of f of 3, the first thing we're going to do is we're going to start with what's inside the parentheses. So we're going to find f of 3. So that means anytime in the f function we see an x, we're going to replace it with a 3. So 2 times 3 is 6, and 6 minus 7 is negative 1. So now that we know f of 3 is negative 1, we can substitute it for our value in the parentheses and plug in negative 1 instead of f of 3, and we'll get g of negative 1. So that means in the g function, anytime we see an x, we're going to replace it with a negative 1. Remember to be, why isn't that square working? There we go. Remember to be careful with your parentheses. We're plugging in a negative number, and what number are we squaring? We're squaring negative 1, so we're going to get negative 1 times negative 1, which is positive 1. Just be careful if you don't put those parentheses in, you'll get a negative 1 because that's different. So make sure you are, whenever you plug in a number, you put it in parentheses. And 1 plus 4 is 5. So therefore, g of f of 3 is 5. So when we put 3 into the f function, take what we get out in the range and plug that into the g function, we get out 5. All right, so let's do a couple examples of that. So if we have these 3 functions, f of x equals 3x plus 2, g of x equals the opposite of x squared, and h of x equals x minus 2 over 5, none of which have an x on the bottom, so all of these functions would have a domain of all real numbers, so we don't have to really worry about that. We're going to find f of g of negative 3. So the first thing we have to find is g of negative 3. So that means every time in the g function I see an x, I'm going to replace it with negative 3. So I have this was the opposite of x squared. Notice I kept the opposite out front. And then I have negative 3 squared. So we're going to get the opposite of 9. And the opposite of 9 is negative 9. So now that I know what g of negative 3 equals, I can substitute that value in to our original. So instead of f of g of negative 3, I'm going to write it as f of negative 9, because negative 9 is g of 3. So in the f function, every time I see a x, I'm going to replace it with negative 9. So 3 times negative 9 is negative 27, and negative 27 plus 2 is negative 25. So f of g of negative 3 is negative 25. So that's plugging a number into one function, and then I'm plugging it into another. The other thing we're going to do today is we are going to plug a function into a function. So we have f of x is 4 over x, and g of x equals 5x minus 2. And we're going to find f of g of x and g of f of x by working again from the inside out. Only this time we're going to replace the function with its expression, and then we're going to plug that expression into the other function and simplify as far as we can go. So let's actually do this example of f of x equals 4 of x and g of x equals 5x minus 2. So the first one it says to find is f of g of x. So to do that, we're going to take f of, and g of x is 5x minus 2. So that means we are going to plug in 5x minus 2 anytime we see an x in the f function. So the f function is 4 over 5x minus 2. And since we are dividing here, there's a possibility we could get 0 on the bottom. So there actually is one number in the domain that wouldn't work for this function, and that number is 2/5. So if x was 2/5, we wouldn't have a function. So 2/5 is not actually in our domain. I'm not making you list your domain today, but that's just for your information. All right, so our answer for f of g of x is 4 over 5x minus 2, because that can't be simplified any further. And then for g of f of x, we're going to do the same thing. We're going to replace f of x with its expression. So f of x is 4 over x. So anytime I see an x in the g function, we're going to replace it with 4 over x. And if I multiply fractions, remember I multiply straight across. So 5 times 4 is 20. 1 times x is x. And 20 over x minus 2 is a expression that cannot be simplified anymore. So g of f of x is 20 over x minus 2. All right, so I have a couple examples of trying this. So if we have f of x equals 3x minus 8 and g of x equals 2x squared, we're going to find g of f of x. This year we are not going to state the domain just because of our time restrictions that come with this being a COVID year. So to find g of f of x, we're going to take g of, and f of x is 3x minus 8. So that means anytime we see a g in the x in the g function, we're going to change it to 3x minus 8. So we are going to take 2 times 3x minus 8 squared. Now remember, you cannot just take this squared and put it on the two terms. You have to, 3x minus 8 means to take 3x minus 8 times 3x minus 8. And remember, to do that, you need to box or FOIL. So if I FOIL or box that out, 3x times 3x is 9x squared. 8 times 3x is negative 24x. So if we have two of those, we get negative 48x. And negative 8 times negative 8 is positive 64. So now if we distribute our 2 times 9 is 18x squared. 2 times negative 48 is negative 96x. And 2 times 64 is 128. So there's no more like terms, there's no more distributing. So our answer for g of f of x is 18x squared minus 96x x plus 128. All right, one last example. We're going to find f of x. So you can plug a function into itself. So we're going to take f of 3x minus 8. So that means in the f function, anytime I see an x, I'm going to replace it with a 3x minus 8. So I'm going to get 3 times 3x minus 8 minus 8. So if I distribute my 3 through, I get 9x. 3 times negative 8 is negative 24 minus 8. And so if I combine my like terms, I get 9x minus 32. That is as simple as it can get. There's no more like terms, no more distributing. So f of x is 9x minus 32. All right, so that is it for this lesson. Your homework is a worksheet. It is you can find it on Brightspace under assignments if you are at home. The worksheet is linked right underneath where it says composition of functions worksheet. And remember to check the activity feed for any virtual assignments you might have. And so have a great day, Cardinals, and make it count.